You may need to take out your intercepts notes to figure out how to do this, but you need to figure out how do you know that given this function, k of x is the same as f of x, which is the same as y equals 3x minus 6, that the x-intercept is located at 2, 0, and the y-intercept is located at 0, negative 6. How do you know this is true? Whatever methods you use, graphically, algebraically, you just have to figure out how could you figure out that those two are the x and y intercepts based on this equation. So I'll give you 5-ish. Was anyone able to figure out how we could figure out that these were the x and y intercepts? So if I was trying to figure out that these were the x and y intercepts, or trying to figure out the x and y intercepts in general, what could I do? What was the question? What could I do to figure out the intercepts of this?
Wouldn't 3x be your x-intercept?
Because right now this is in slope-intercept form, so this would be your slope.
Would be 3x divided by negative 6.
Why would I divide by negative 6?
So you make kx.
By itself.
Would you divide it?
So we could divide not by negative 6, by 3, but we'd have to do something first in order to end up there.
Get to not the slope-intercept, the other form,
The standard form.
the standard form by adding the 6 to y and dividing by 3.
So let's change this to y. And you're saying add 6 over here. So we have 6 plus y equals 3x. And then you said divide by 3. So that's how we would find it, but we have to put something in for y.
1.
0. So if we're looking for an x-intercept, also, yes, correct, that is not standard form. Because we have to move the 3x over. Anyway, if I put 0 in for y's place, and then solve for x, 2 would equal x, and then we could write that as the ordered pair. How could we know that this is the y-intercept, 0, negative 6?
You plug in 2 for x.
Plug in 2 for x. Because will that give me negative 6? Maybe 0. That just means that this is true. But how could I get the y-intercept of negative 6? It's going to be very similar to what we just did to find the x.
0 on 3x.
If I put 0 in for x and then solve, I get that negative 6. So those were algebraically. If you wanted to know that these are, in fact, the x and y intercepts algebraically, you could have done any of this. You could have also graphed it. So you have access to Desmos. You could have put this equation in, 3x minus 6. Let's do that really quickly. This is the one that I escaped. There we go. If I was looking at the graph, I can see on my graph that it crosses at 2 and negative 6. That would have also let me know for certain those are my x and my intercepts. You could have put that in your calculator, all of those things. Right? So, quick reminder of how intercepts work. Before we get into our notes for today, let's talk about so many things. First, look at your course calendar. So you'll notice that this is a shorter unit than last unit. It's 3 objectives instead of 4. You'll also notice that the quiz, it'll go quiz and then flex day and then tests, not like we've been doing it because of homecoming and there. So on the 19th will be your quiz. It'll be just like every other quiz, open note, collaborative, which is why we're still doing it on the 19th. But then when I see you guys again, it'll be a flex day to review for the test on Wednesday. Take notice of the Delta Math. So we'll have one due this Friday on what we talked about today. The rest of the Delta Math will all be due on the 27th, so that should be 2 due on the 27th. So also keep that in mind. This unit, everything from this unit, the Delta Math, the quizzes, the tests, is all going to go on quarter 2. So when you look for these grades, when I send out reminders about looking for grades, you have to look in quarter 2. That being said, what your grade is right now will be your grade unless you retake, do missing work, any of those things. So if you've not been coming to my office hours, today would be a great time to start. To work on retake work, to turn in missing work, because November 2nd is the last day to work on retake work. After November 2nd, I am no longer taking retake work. November 1st, sorry, I mixed that up. November 1st is the last day to complete retake work entirely, but November 2nd is the last day to retake. So if you have completed all your retake work by the 1st, you can retake on the 2nd at the latest. But if you have not completed your retake work by the 1st, you're not retaking on the 2nd. This would need to be an after-school thing, not in class. Also for the review. So, whatever grades you need to retake from Unit 2A/Unit 1, you need to get that done as soon as possible. We have 3 weeks left of the quarter, rounding. So, I'm after school Tuesday, Wednesday, Thursday, every week, unless other things come up. So, if you need to be in my office hours every single day, that's fine. But come get your grades up if need be. Do we have questions about any of that? Okay. I'm also going to add in the small thing. If we have time, which we usually do at the end of class, if you are good on whatever topic and you don't need to practice or do the Delta Math, you could be doing retake work in class as well. Alright. So this unit is going to be like a continuation of last unit, but different things as well. So everyone go ahead and put your phones away. Not in your hands, not on the desk, not in your lap. You should have these notes in front of you, which was on your desk. Over, Caleb. So today's lesson is going to be on parallel and perpendicular lines. Some you may remember from geometry/algebra, some you may not. So we're going to talk about definitions and things like that first. So I'll let you guys write this stuff down. Okay, I'll read it out loud just in case you can't see it. So for parallel lines, the definition are lines that never intersect. So they're never going to touch each other, they're never going to cross. Algebraically, we know two lines are parallel if they have the same slope. You may or may not remember from geometry that this is the symbol for parallel lines, the two lines. So instead of writing out the word parallel, if you want to put those two lines, you can do that. Perpendicular lines intersect at a 90-degree angle, so they make like a perfect T. Algebraically, we know two lines are perpendicular if they have negative reciprocal or opposite slopes. We'll talk about that here in a moment. The symbol for perpendicular is this upside down P. One more thing to break down the definition. Negative reciprocals are, if you have a fraction, you're going to flip it, and the sign is switched. So if it was like 3/4, now it's negative 4/3. You take the whole fraction, you flip it. If it was positive, you make it negative, and vice versa. So fraction flipped, and the sign is switched. Once we all have that written down, we're going to talk about some negative reciprocals. So if I had 3/4, now I just gave this example, but if I had 3/4 and then I took it and I flipped it and I made it negative, what would that be? Negative 4/3. Right. What about 2? So it is going to be negative, but remember all whole numbers have a 1 under it, so if I flip it, it's going to be negative 1/2. Negative 7/8. What would the negative reciprocal of that be? 8/7. So flip it and make it positive. The negative reciprocal of 1. -1. It's going to simplify, but it's going to be -1. Right? Here we have to be a little careful. Because 0/1 is 0, we know that. If I flip that and made it negative, what is anything over 0?
But it's
Something specific. It's not 0. You're going to get an error. It's a specific type of slope, undefined. So this one's going to be a tricky one because you're going to want to take it and flip it, and you're going to say these aren't parallel or perpendicular because they don't look the same, but you have to remember that this is undefined. 0 slopes and undefined slopes are perpendicular by default. Alright, we'll have time to do maybe one of these and then we'll go to lunch. So, you are given 2 sets of different segments that we need to decide if these are parallel, perpendicular, or neither. The fastest way to do that is to find the slope. So, as a reminder, and this is over there as well, slope is found by y2 minus y1 over x2 minus x1. When we come back from lunch, make sure everyone has their calculator. So we're going to do this twice. We're going to label the first one x1, y1, x2, y2. And we're going to find the slope for AD. So 6 minus 3 over 2 minus a negative 2. And let's subtract. What would we get when we subtract? 3 over 4. Right, then we're going to do the same thing for CD. Label that x1, y1, x2, y2. So this would be 3 minus 0 over 3 minus a negative 1. And let's subtract. 3 over 4. And now we're looking at the slopes. If they're the same, they are parallel. If they're negative reciprocals, they're perpendicular. If they're neither of those, they're neither. So these would be parallel, perpendicular, or neither. Parallel, parallel. I'm just going to write the symbol because I don't have space, but you can write out the word or use the symbol. Okay. Do we have any questions on that one? We'll do a couple more when we get back in class. So let's label this x1, y1, x2, y2. And then we can put this in our formula, 4 minus 2 over 5 minus 0. So you can either subtract by hand or put it all into your calculator as alpha y equals, figure out what that would be. Let's do the same thing for CD. x1, y1, x2, y2. We have 3 minus 8 over 3 minus 1. Negative 5 over 5. And now looking at these slopes, would these be parallel, perpendicular, or neither? Perpendicular, because they're flipped, but also one is negative, one is positive. Questions on that one? I'm going to do one more of these and then switch gears. Alright, so let's do number 3. Same process. We have 6 minus 8 over 2 minus a negative 1. Negative 2 over 3. And then let's do the same thing for CD. We have 3 minus 2 over 3 minus a negative 1. 1, not half, but 4. Okay. So are these parallel, perpendicular, or neither? Neither. So neither cases are a couple different things. Either the numbers have nothing to do with each other, like this one, or maybe they look parallel, like they have the same numbers, but one is negative. Or they look opposite, but they are both positive or both negative. So be on the lookout for any examples like that. Those are all neither cases. All right, questions on how to find if they're parallel, perpendicular, or neither from points?
How do you know if they're parallel or perpendicular?
By looking at the slope. So if they're the same, they're parallel. If they're negative reciprocal, so opposite, but one positive and one negative, they're perpendicular. This one wasn't either of those cases. I didn't write the answer, but it was neither.
Oh, so it was like.
Alright, go on to the next page. let's do 5 and then we'll move on because I forgot 5 is a special case. Alright, so I'm going to rewrite the formula up here just in case we need it. So we're not flipping back and forth. Let's do our AB, x1, y1, x2, y2. We have 7 minus a negative 2 over 0 minus 0. Subtract, tell me what you get. 9 over 0. So I'm going to leave that like that for now. We'll come back to it. And talk about CD. So guys, if you can't focus, you're going to go back to your seats.
Alright.
Alright, let's do the same thing for CD. Negative 5 minus negative 5 over 6 minus 3. What would that subtract to be? 0 over 3. So looking at these right now, what would we say? Parallel, perpendicular, or neither? Okay. So that's what I thought you would say, but we have to remember what these simplify to be. What's anything over 0? That one's undefined. And 0 divided by anything? Not undefined. 0. Now looking at these two, are those parallel, perpendicular, or neither? Perpendicular. So this doesn't look like they would be perpendicular, but we have to remember what they actually equal. So this one would be perpendicular. Okay. Opposite would be true if you got 2 undefined or 2 zeros. Those would both be parallel. But you would have to remember to simplify it at the end. Alright, so we found parallel, perpendicular, or neither by points. Now we're going to talk about equations. If they give you the equations and they're in slope-intercept forms, you just have to look at the slopes. So for number 9, if I'm looking at these slopes, are these parallel, perpendicular, or neither? Are they 2 different slopes? No, so they're parallel. They're exactly the same, so they're parallel. If one was negative, then that would be neither. Right, what about number 10? Parallel, perpendicular, or neither? They're negative reciprocals of each other. Okay, and then what about 11? That would be a neither case. Here we have the same numbers, but one is positive, one is negative. But that alone doesn't make it perpendicular. So this would be neither. Questions so far? So that's if it's given, they're both given in slope-intercept form. If they're not given, so like 12, we have to solve it first and then figure that out. So let's think back. If I were trying to get this into y equals mx plus b, what would be my first step? I'm trying to get this back into this format, but I gotta get y by itself. What would we do first there?
Divide 6.
We could divide 6, but we could also subtract x. So when we subtract our x, we're going to switch the order. And then divide everything by 6. So that y equals negative 1/6x plus 5. So now we have 1, but the other one we still have to solve. How would we solve this one? Get y by itself. Divide everything by 3. we have y equals 6x minus 2. Are these parallel, perpendicular, or neither? I heard like whispers, but I didn't actually know what you said.
Neither.
Why neither?
Because it's 5 and -2.
So we're looking at the slopes, not the
Oh,
y-axis.
it says there's no, it's not negative, but there's no no.
One is. So you're saying it's which one? So these are negative reciprocals of each other. One's positive, one's negative, one's the flip version of the other. So what would that be? So anytime you see a negative reciprocal, that's perpendicular. I need you guys paying attention.
No, actually, no.
Okay. Do we want to do another one like 12, 13, or 14 before we try 15, 16? Which one? Said 14. Alright. 14. How would we solve this one for y? Subtract 3x. Guys, go back to your seats. Go back to your seats. Go back to your seats. Yeah, Wilbur needs to see that. Subtract 3x from both sides, rearrange it. You're still going to get y by itself by doing what? Dividing by -1. We have y equals 3x minus 2. The same thing for the other one. What would be our first step? Minus, what was that?
4. Oh, no.
Not first. Would subtract this, but the x term.
12.
And then we can rearrange negative 12x plus 4.
That's getting weird.
It's so good.
Okay, next up, to get y by itself.
Minus -2. Add.
I heard minus, I heard add. What? But divide by negative 4. So y equals 3x plus 1. Now if we're looking at these two equations, are these parallel, perpendicular, or neither? Are these negative reciprocals of each other?
Other parallel.
Parallel. Those notes behind you. Alright. Questions on number 14. Okay. For 16, think about the types of slopes those would have. So I'm going to write off to the side our favorite words. Horizontal lines have 0 slope and our y equals. Vertical lines have undefined slope and our x equals. What are the slopes of these two lines?
I meant 6 and 8.
Those are the slopes, Jacob.
Undefined and 0.
Undefined and 0. So These are two slopes. Are these parallel, perpendicular, or neither?
Perpendicular.
Perpendicular. So if you get something like that, you have to remember the slopes. They're not talking about the equations that they're given. They're talking about the slopes. Right? Questions on that one? Right. Now that we understand how parallel, perpendicular work, now we're going to actually apply it in a different sense. So go on to the next page. Alright, so I'm going to have you fill this in. That parallel lines have the same slope. Perpendicular lines have negative reciprocal slopes. What we're doing with this part is we're going to be given some equation. It's going to say it's going to pass through some point. And then it's going to say whether it's parallel or perpendicular. And we have to come up with another equation that is parallel or perpendicular to the original. It's going to seem like a lot. But the work that we do is going to be very familiar because we've done this process before. Right? We are going to go back to using our point slope. So let's write that down. That's why I said it would look familiar. Remember, that's also, if you forget, up here, multiple places. The pink one is one of them. Somewhere else is another. So for number 1, we have our point. That's going to be our x1, y1. This is parallel. So if it's parallel, the slopes have to be the same. If you want to write this as a side note, you can. The slope has to be the same. They give us some equation. We're going to completely ignore the y-intercept that they give us. Cross it out, scratch it out, something. You don't need that number at all. If it has to be the same as this equation, what would our slope be? -4. So now we have our x1, our y1, our m, and we're going to put those into this equation. Y, remember the y and the x, stay those, minus our y1, 7, equals our slope, -4, x minus our x1, -2. So we have our equation. Now the process is just like with what we were doing when we were writing. We're going to get this back into slope-intercept form. So we need to combine this, make it a plus. Before we can distribute. And then the last step to get y by itself. Add 7 to both sides. So we have y equals -4x minus 1. Now if we look at that original, these have the same slopes. They have different y-intercepts, which is also a definition of parallel lines. They have to have different y-intercepts. So I can say that this line is parallel to this one, which is our goal. If we were to graph this, which I will do later, this would be parallel to this, and it would go through this line. So they'd be two separate lines, but the one we just drew would go through that point. What questions? Yes.
You said that the y-intercept doesn't, or shouldn't be the same for parallel lines. If it is the same, is it still parallel?
If they are identical, like this was also +1, these would be the exact same line, so they wouldn't be parallel. Other questions on that process? Are we going to answer anything like that? Alright, we're going to do another one of these examples, but in this case, the equation given is not in slope-intercept form. So we have to get it in slope-intercept form first. Alright, same as before. We have to write an equation. This is our x1, this is our y1. Parallel, the slope has to be the same. But right now, we cannot say what the slope is. We don't know what it is. We have to solve it. So how could I get this back into y equals mx plus b? So not add, not divide, but subtract the x, get rid of it, to the other side. So we have negative 3y, we're going to rearrange, equals negative x plus 9. And then, to get y by itself, divide everything by negative 3. We have y equals 1/3 x minus 3. Again, if you want to cross out that negative 3, it doesn't matter, so we don't need it. It's not going to be used. That way it doesn't confuse you. If the slope is the same as this equation, now this is not our final answer. This is just this equation rewritten. What slope are we going to use? 1/3. So now we have our slope. We have our x1, we have our y1. Now we can use that point slope to find our new equation. It's a lot. So y minus y1 equals our slope of 1/3 times x minus 3. What do we think would be our first step? Sure. We can also make this a plus at the same time. So in your calculators, go ahead and do 1/3 times negative 3. Two more. Your calculator number is 28. 28 may not be in the grab a different one for today, but in the future, that is your calculator number. Right, and then to get y by itself, subtract 1. So y equals 1/3 x minus 2. This equation has the same slope but different y-intercept than our original. They are parallel lines. Questions on that one? Any confusions as of right now? It's just going to get not harder, but more complex. There are more steps with a perpendicular. Let's try some perpendicular ones. Process is basically the same, but a little different. Because this is still our x1, this is still our y1, but if it's perpendicular, it needs to be a negative reciprocal. So we need to take the 2 and flip it and make it negative. So what would be our new slope? Not negative 2, but it will be negative 1/2. This is going to be the first step for all of your perpendiculars. If you don't do this, but do it at the end, your whole problem will be wrong. Right? Now that we have those things, the work is the same. Y minus y1 equals your slope times x minus x1. Yes. You made a pass. Okay. Then we can distribute negative 1/2 x, multiply negative 1/2 and negative 4. Tell me what you get. Should be positive 2, so you're multiplying 2 negatives. But 2, yes. Right. And then subtract 3 from both sides. So y equals negative 1/2 x minus 1. And if we look at this one compared to this, the original, the slopes are changed. One's flipped, one's negative. The y-intercept doesn't matter. Correct. We should have been adding 3, so that would be 5. My bad. Right. So parallel lines, the slope have to be the same, y-intercepts have to be different. Perpendicular lines, the slopes have to be negative reciprocals, one positive, one negative, and flipped. Y-intercepts doesn't matter. They can be the same, they can be different, it doesn't matter. Do we have any questions on that process? Any of them? How we got the answer, how we started it, anything? As I mentioned before, if you change this at the end, you're not going to get the same y-intercept, so make sure you do that first. Right? This is like the hardest it's going to get. So just like the one we did for parallel, we're going to have to change this, rearrange it so that we're solving. We have our x1, we have our y1. We need to get this back in slope-intercept form. What would be our first step? Subtract 5x. We have 3y equals, I'm rearranging, negative 5x minus 21. And then to get y by itself, divide everything by 3. We have y equals negative 5 over 3x minus 7. Again, that's not our final answer. We still have to keep going. If you want to cross out the minus 7, go for it. We need a slope that is a negative reciprocal of the one we have. So we need to take this, flip it, and make it positive. What would that new slope be? Three over 5. Again, if you do not do this part after you've figured out your slope, the rest of your answer is going to be wrong. Now we have our m, our x1, our y1. We can put those all in. Y minus our y1 is 1 equals our slope 3/5 times x minus a negative 5. What's our first step? Make it positive, change that first. So if we start distributing and we haven't changed that, we're going to end up with wrong things. Right. Then we can distribute. So 3/5 x plus, what's that going to be when we multiply it? 3. And add 1. So our final equation, y equals 3/5 x plus 4. A lot of work. But at the end, we can say that these two equations are perpendicular. So we're cross. Everything else in this packet is practice. So I'm going to ask if you have any questions in any of the practice that you want to see you go over before I let you practice on your own.
I don't have a question. So for this, is this just kind of like confirming what we did to get the m equals? Or
Not quite. So I said I was going to do this, and I'm going to show you this. And then hold that one. Alright, so I'm going to look at the example we just did. Okay, so I'm going to put in the original equation that was already there. 5x plus 3y equals negative 21. So we have that original equation. I'm going to put in the point that it said it goes through. I'm going to write the equation that we came up with. Y equals 3 times x plus 4. So, the blue line, actually let's change color so we can see it a little bit better. Okay. This red line was the original. It's going through that point. It's a little off, but it should be going through that point. The purple line is the one we solved for. That's also going through that point. That is making this perfect t, x, whatever, that's perpendicular to the other one. That's what we're trying to find. Another equation that's perpendicular to this one that also goes through that point. So graphically, if you wanted to check it, you can do exactly what I just did. If you type yours in, and, okay, that was a bad example. And it looks more x-ish than t-ish, they're not perpendicular. Something went wrong when you were putting in your slope, or finding your slope. Okay. Other practice questions we want to see you go over, or questions in general? So as I mentioned earlier, you guys have a delta math on parallel and perpendicular lines due on Friday. You have a bunch of practice in this. Use this time to practice any of that. You should be working on one of those things, delta math or practice from the notes. Let me know if you need my help, have questions. Use this time wisely.